Hello, and in today's STM32 programming with a blue pill, we are going to be blinking some LEDs. Okay, so first thing we want to do is to duplicate the base project setup. So first what we do is we say File, New, STM project from existing STM32MX configuration file, so the IOC file. So we just say from that file, that will bring up a dialog like this. Then we need to select the ICO file. So from our base project setup, we just say project.ioc. And then we need to rename the project, and that's going to be Blink, and it's going to be a C++ project. Then we say next, we say copy only the necessary library files, and then we just click finish. And that will duplicate our base project setup. As you can see here, our clock settings are exactly the same. Project manager, code, settings all stay the same. So for the LEDs, on a blue pole, we have a LED connected to PC13, which is the onboard LED. Now we can simply just click on this, and then we can select what the GPIO is going to be used for. Since it's an LED, we're going to be setting it as a GPIO output. And then we can right click this and say enter user label, and we're going to make this LED 0. And then for the other 8 LEDs that are connected externally, these LEDs are connected on the top half of the STM32. So this is going to be from PB9 all the way to PA15. So we're just going to repeat this process by setting them all as GPIO output. And then we are also just going to rename them from LED 1 to LED 8. Okay, and that's all our LEDs set. Now you can configure your GPIO here under System Core, and here you can set the individual settings for a pin. Also see it flashes based on what pin you already have selected. So here you can set pull-ups, the initial output level, and then if it's a high speed or low speed pin, what type of output it is. For our case, we're going to initialize all the LEDs as high because we are syncing the current through the STM32. Say hi. Okay, now we're done editing the pins. Now we can just save our project, and we say yes, we want to generate the code, and yes, we want to switch to the C perspective. Now in core, we're going to make a copy of our C main file, paste that in, and we're just going to call it main.cpp, and that is going to be our main file. So we exclude the main.cpp from our current build. So the resource configurator exclude from build, we exclude it from both debug and release, and we click OK. Okay, first thing, we need to clean up this project, get rid of all the comments because I'm not going to be using that. Besides, the generator doesn't want to generate the C++ file, so no point in keeping the comments. Okay, and that cleaned up our main file substantially. Next thing we want to do is we want to create a new source file, and we're just going to call that GPIO_whole.h. We move the .h to our include folder. Then we want to create a new source file. So we're going to name that GPIO.cpp. Actually, we're going to delete this. New header file GPIO.h. And we have to say _whole because the name already exists. And that adds our header guards. Okay, then we go to our previous C main file. We can see GPIO init. We can have a look at that function. So this function basically initializes the entire GPIO. Every time you regenerate your project, if you change configuration, this file gets altered according to your needs based on a template. Here we can see it already, it initializes our clock for the GPIO, creates a structure, writes to the pins, initializes each GPIO individually, as well as in a group setting if required. So we go to our GPIO hull, we create a class called GPIO base, and this is going to be our base class, public, and then our private sections of the class. And then we're going to call our constructor and create a destructor in here. And we're going to create a static bool and say is init, and that is practically our base class. And we're going to add a static function and we call that init. And it's going to be of return type void and take in void parameters. Then we include include GPIO.h, and then we can go to the CPP file, which we are going to rename to _hull. Just fix the header, and that is going to include GPIO hull.h, and then in this function we can close down the outline here, give us some more space. Then we see h file, so we copy the variable, the static variable, we copy our base class, and the default initialized value of this is going to be false since our GPIO is not initialized if we call this base class. Then we are going to build our constructor, and that's going to be empty for now. Then we add our destructor, and then we have our static function, which is the init function. So we just copy that, create it, we set it to the GPIO base namespace, and then in this init function we are going to say if GPIO is init, we simply return. If it is not initialized, then we are going to call this mx GPIO init function. So we copy this function and then we paste that in, and then we set the GPIO base is init equal to true, and that is the init function, and then we can call the init function in our constructor. And for this tutorial, I'm not going to be handling the destruction of GPIO pins, since it's very rarely you need to destruct the GPIO pin. Then we have our next class, and that's going to be a dout class. We duplicate the internals, replace our constructors, and we remove the unwanted parts of the GPIO. And then we also inherit on a public space the GPIO base class. Now to do a GPIO write, we go have a look at the functions here. We can simply just right click and say go to declaration. That will take us to the functions, and then Control Shift Tab will take us to the header file. When we scroll down, we can open the outline here and search for the functions we are looking for: GPIO net, GPIO dnet. Then we got read pin, write pin. So we want the write pin function. So for all of the functions here, we require a GPIO type def type and then a uint16 for the pin. So in our constructor for the digital out, we are going to need a GPIO type def and a GPIO pin. And then in our private variables, we do the same. We just give it an underscore to indicate that it is private and that we have permanent storage of the pins. Then we switch back to the GPIO hull.cpp. We quickly, let's just add a few lines here. So we copy our constructor, and that's going to be of namespace dout. And then we set the variables with our constructor, comma GPIO pin. We give it a brace, and then we just move in our parameters. That will construct our dout. Now I'm also not going to create a destructor for this. Technically you can use the dinit function for this, but rarely do you need to destroy your GPIO pin. So now we need to be able to write to the digital out so that we can actually have something with the output. Actually, now that I think of it, we have to add a initial state. So that's going to be uint. Let me just double check that. And that's going to be of type GPIO pin state. We say pin state. And we add that and we give that name state and we say that has a default parameter of, let's see what's the available pin states. Since most likely you're going to be syncing your current, we'll make the default pin state as set. And we go back to our CPP file and then we just quickly update the constructor with the GPIO pin state. Add that to the next line for the initialization. Now next what we create is a public function to write to the GPIO, which is going to wrap the whole GPIO write pin. So we create a function here that is going to be of type void and we just call it write, and that is going to take in a parameter of GPIO pin state. And we simply copy over the function, add the namespace again for the class, and we copy the GPIO pin write function. Now we simply just fill in our parameters. So GPIOX, whichever pin we are using, and the state is going to get passed in. And then in our constructor, we can call the write function and pass it the state that we give to the constructor. Then we want to add the functionality for a toggle. So we just add another function of type void. We call it toggle, and that takes no parameters since we don't need to pass anything to it. We just make that a lowercase. And back to our C, just for completeness sake, just add a void, and that's going to be namespace d out. We copy the toggle pin function and simply pass in the parameters from up here to the GPIO write. Okay, then we have toggle. Okay, so the last function we're going to add to our class is going to be read, so that we actually know what the current pin state of the LED is. So we can just copy this whole function over here. It's actually mostly identical to the other three. Then we just have the whole pin, and that needs to return a GPIO pin state for us. And then we simply just return over here, and then we can copy this and then add it here. Just remove the namespace operator, and that's the basics of the class. So now we can add it to our C main. Apparently I cleared out the wrong file. Okay, so now we're back in our main function. We can actually change this to GPIO whole since it's already included in our GPIO whole file. Now we keep our whole init over here. We keep our system clock config over here, and we can get rid of our MX GPIO init since the base class already handles that for us. So we can create a type of digital out like this. You can find your declared variables in the main.h file. So each one has a pin and port associated with it, and you can see the macros follow a pattern. So 0, 1, 2, 3, 4, 5, 6, 7, 8 all the way. So we can simply just create one of these, and then we just create 8 of these, and then we just pattern match. And that's all our LEDs initialized, and that's going to be on the startup is going to be low. So we can simply build with our hammer icon over here. Check that everything builds. Everything seems to be building fine. And then we can quickly upload our code. And now if it's the first time you're uploading a project, it's going to ask you about your debugger. Maybe it doesn't do this with an ST-Link, but it does do it with a Segar J-Link. Here you can select your debugger, and for my case, it's going to be a Segar J-Link. And then you can configure your project. By default, most of the parameters should be what you want it to be. And then we just click apply, and then we click OK. And that will start flashing the code onto the STM32. And as you can see, there's not much going on the STM32 itself, because we initialized all the pins as low. So if we want a pin to be high, I'm going to set 2 pins as high. We're going to say GPIO pin set, and we're going to change it to reset. 2 of them. So the onboard LED is going to be on, and one of the external LEDs is going to be on. So we just quickly flash that on. Just give me a moment while I debug this. Actually, let's take you through the debugging process. To debug a project, you go through, you click the little bug icon here at the top. It's going to configure the debug perspective. Yes, we want to switch to the debug perspective. Oh, because it's running the C main file. Fantastic. Okay. We close that down, we shut down the debugger, and then we delete the CMain file if it insists on using it. Then we delete our debug. Then we try again to flash, and it jumps all over the show. And now, if you can see on the cam, the one LED is on, and you can see the onboard LED, which is the green one, is on, which would be... Oh, if I can see... In here, you can see that green LED right there. Hopefully that's clear, but you can clearly see the one external LED being on. Okay, now what we can do is we can create a running LED sequence from this. In our while one loop, we can say hull underscore D, I believe it's delay. Yes, there is delay. Let's say every 1 second. No. 250 milliseconds. If you want to have a look at the function, you can say open declaration, then it will take you to the documentation here that handles it. Okay, then we can take D out, and this does not actually help us much. Then we can give these names, like LED 0, so that we can access them throughout our code. Let's just pattern match that. And we can take LED 0 and use the toggle function, and we take LED 1 and we also use the toggle function on it, and then we can run the code again. Now you can see both the green and red LED blinking. Then we can remove this initialization for the 2 LEDs. Then we include a C++ library, and that's going to be array, so that we have access to array types. Okay, we can call this LED bus. So we include our standard or STD. We say array, and that's going to be a template of type D out and of size, that's going to be our LED bus equal to LED 1. That's going to be LED 1, 2, 3, 4, 5, 6, 7, 8, and that's all our LEDs. And now we can create a for loop. So for uint32 I equals 0, comma I is less than LED bus dot size, comma I plus plus. And then we can remove this as well. And then we say if I equals 0, then we say the LED bus of LED bus size minus 1. So this is going to be the back of the array. We simply write that to 1, and we do a else statement. And then we just copy this line. It's going to be I minus 1. So this is going to clear. So going to switch off the LED. So this is going to be pin set actually. So this is going to turn off the LEDs because it's inverted logic, because we're syncing current. And then we simply say LED bus I dot write is going to be pin reset state, and then we simply just add our whole delay of 250 microseconds in there, milliseconds in there. On every cycle, we will toggle the LED 0, so the onboard LED. Then we are going to iterate through every 250 milliseconds by switching the previous LED off, and then switching the current LED on and delay 250 milliseconds, and then repeat that for the size of the LED bus, and then Bob's your uncle, we have running LEDs. So we flash that to our STM32. Now, for some reason, if I flash it, it jumps around in the code. That's completely normal. It's annoying, but it's normal. Now, as you can see, the LEDs are running. Unfortunately, my camera is not quite picking it up, but you can see the LED moving, and then you can see the onboard LED toggling on and off, even though it's very dim. I can actually switch off the flashlight, then we can see the LEDs nicely going in a row, and you can also see clearly the onboard LED flashing on and off. And that's an introduction to using the GPIO as outputs on an STM32. A like, share, comment, and subscribe is always appreciated. Thank you. Have a nice day.